Hello. I don't want to make this long because I've already had to do one take because I didn't read the full problem. So this is my second take. Um, I'm going to assume you know how integration by parts works already. If not, I can do a quick explanation on that over text. But for this, it seems a little bit more complicated of what they're going for here. So I'd rather do that first. So the way I set up integration by parts is the most visual way of doing it. I create sort of a table. So the formula for integration by parts is u dv, or the integral of u dv is equal to u times v minus the integral of v du, which is like a broken down version of the multiplication rule or something. There's like a very nice proof for it, but for now we're going to worry about what they start off at the beginning. So they start off with u is equal to sine to the power of n minus 1 times x, and dv is equal to sine x dx. So what they're doing here is they're basically separating that first equation, the sine to the power of n of x, into two parts. And we know this because when you would multiply these two together, which is what you need to do at the beginning right here, you just get the original thing back. So if we were to multiply sine to the negative 1 with sine to the x, we can say this is the same thing as calling it to the power of 1. And by the power rule, or by rules of power, we know that if we were to combine these, it basically would just be like adding the powers. So we would get sine to the n minus 1 plus 1 of x, and these negative 1 and positive 1s would go away. So that's what they're doing in the first step. The second step is basically all of the tedious stuff of it. So they just find the remainder. Because they've established u as this and dv as this, now they're going to find du and v, which you need for the last part. So u in this case, or du in this case, is fairly straightforward. Bring down the power, decrease the power, and chain rule it, basically. So by the power rule, we know that you bring down the power, which is n minus 1. That is the current power. To the front, multiply it by whatever was there originally, and subtract 1 from the power. Next, you need to do the inside because it's not just an x in the middle, there's sine x in the middle. And by chain rule, we know you just multiply by the derivative. The derivative of sine x is just cosine x, and dx at the end. To find v, we're given dv, so we just find the integral. The integral of sine x is negative cosine x. So now we have our 4 variables set up, and with these, you can just plug these variables into this equation up here up at the top, and that is literally where the formula is derived from. Putting it all together, looks like we get negative cosine x sine negative, or to the n minus 1 of x minus the integral of negative cosine x times n minus 1 sine n minus 2 x cosine x dx. We then can combine the cosine x's and distribute the n minus 1, it looks like. Oh, we can just take out the n minus 1 because n will always be integer. N is not a variable. Or it is variable, but only based off integers greater than 2. So we can get this equation Oh, that's weird. Okay, so basically cosine x sine n minus 1 x minus n minus 1 integral. So they combine the cosine x's and sorry. Oh, they take out the negative sign. So they take out this negative sign and they cancel out with this one. Cosine squared x multiplied by sine n minus 2 x. And what they do here, which is like really, really tricky for some reason, is that they use the Pythagorean identity on this cosine squared x. So I'm going to get some of the stuff up here. I really wish this whiteboard gave me a bigger eraser. They keep the formula as normal and then just split this integral into 2 using that cosine of x plus n minus 1 sine n minus n minus 2 of x dx minus n minus 1 integral sine n x dx. So basically where this came from this sine n of x originates from this cosine over here. So what they did is they did 1 minus sine squared of x, and that sine squared where did it come from? Wherever it came from, like, I probably have to do some more math, and I probably will, and I'll just send it to you after the video. But basically, short thing short is that they distribute this across this entire thing. So it would be 1 minus sine squared x, because that's the Pythagorean, times sine n minus 2 of x and that becomes sine n minus 2 minus sine n of x, because n minus 2 plus 2, and then those cancel out. So it took me a while there, but you still get back to the regular nx. That's where the minus comes in as well. So after that, you finish integrating this entire thing. Well, here we're kind of in a predicament here, because this is our original equation, right? This sine n to the, n of x. So what we can do is basically this is what we started with, right? Sine to the n x dx equals this entire thing. Negative cosine x sine n minus 1 x plus n minus 1 integral sine n minus 2 x dx minus n minus 1 integral sine n x dx, right? We can add this back to the other side, this entire section back to the other side, and we get positive n minus 1 plus 1, because of counting in our original, sine nx dx equals whatever else is here. And then we're left here with just positive n. We can divide n on both sides to isolate that sine n of x. And what we're left with is the equation that you're given there. And for time's sake, I'm not going to write it down, but if you do like the quick n division, you'll see some like key features of that equation, like the n minus 1 over n. You also get the negative 1 over n at the beginning, so a lot of the features are there. This is the full proof of it. I wasn't expecting to go 12 minutes into it, but you get the point. This is how they're showing you how to use integration by parts, by taking those 4 variables, u, v, the derivative of u, and the derivative of v, and plugging it into that equation. This whiteboard app is not allowing me to use it, but u dv, or integral of u times the derivative of v, those are separate variables by the way, is equal to u times v minus the integral of v du. That's basically what they're showing you. I don't know why they chose this as an example. It is a horrible example. They could just use problems. But if you would like a full derivation of this problem, feel free to let me know and I'll make another one. But for now, I hope this explains this problem specifically. I don't know why they're making you use this problem. You'll honestly never use this formula. So it is a nice proof though. So I hope you enjoyed it. This should be uploading in about 10 minutes from when I record it. Bye.